What's going on, Algebros? Welcome to another video where we're going to rationalize the denominator of this fraction here. We're going to do so by utilizing the conjugate of the denominator. We have some modifications to the instructions, namely the addition of a second statement here. It says assume that all variables represent positive real numbers. And the reason why that's here is because we have a variable as part of our denominator. Trapped inside that square root, i.e. the square root of x. So we'll start out like in the last video where we'll first identify the conjugate of square root of x minus 5. Okay, so recall that it's as easy as just using the opposite operation of what's separating the two terms here. So our conjugate is going to be the square root of x plus 5. So we'll multiply the denominator by square root of x plus 5. And again, we'll have to also do that to the numerator just by the golden rule of fractions. All right, so let's carry on with the rest of the algebra here. On top, I'll just write 3 in front of quantity square root of x plus 5. In the denominator, much like we saw in the last video, we're going to have to FOIL. All right, so let's go ahead and do that. First part of our FOIL is radical x times radical x. That's going to give us radical or square root of x squared. Then we have to take the square root of x, multiply it to 5. Both are positive, which is why I'm writing plus 5 radical x. And then we'll go ahead and subtract 5 radical x. And then distribute this negative 5 to this positive 5 to get minus 25. So as you probably noticed in the last video, when we multiply a number by its conjugate, or in this case, the expression radical square root of x minus 5 by its conjugate, we actually get some simplification. And it's kind of a magical simplification because the expression simplifies to where there are no more radicals involved. That is, there are going to be no more square roots here. So let's see how that works. All right, so I'll go ahead and start another line of math here with the numerator, 3 quantity radical x plus 5. And in the denominator, we have the square root of x squared. So we know that the square root will cancel out the power of 2. Now, because it says assume all variables represent positive real numbers, we do not have to worry about the absolute values. We could just write that simply as x. We also have some opposite terms here, positive 5 radical x minus 5 radical x. These are going to cancel out from each other. And the negative 25 here doesn't combine with anything, so I'll just have to write it back down as minus 25. So there's really nothing left to do in this example. There really is no simplification. We're not going to mistakenly divide anything from on the top with anything in the bottom. And that's because x minus 25 is in and of itself a single expression. The only way you could cancel out x minus 25 is if it had a matching factor in the numerator. And likewise, in order to cancel out something like square root of x plus 5, I'd have to have a matching expression in the denominator. So long story short, this is our final answer. And that concludes a second demonstration of how to rationalize the denominator when we have expressions involving two terms in the denominator. All right, so that's it for this one. Thanks again for watching. We've got one more to go, so I'll see you in that video. Thank you.